Hello! Today in class we're going to solve some more examples in which we're going to apply the property of degree. But in our examples, the exponent will be written as a letter expression. But when solving these examples, we use the same algorithm. For example, if we need to find the value of the following expression, 2 to the power of m divided by 2 to the power of m minus 1. Notice that the exponent is written down as a literal expression, but if the base of these expressions is the same number, then we can use our properties. We'll write it like this: 2 to the power of m. When we divide, we subtract m minus m minus 1. It's important to note that the exponent of the denominator we have written in brackets in order not to make a mistake in the sign. Now let's open the brackets and the result is but 2 to the power of m minus m but plus 1. The point is that m minus m sum is 0. And then the answer is 2 to the power of 1, or the number 2. When we convert expressions where the exponent is a literal expression, we use the same properties. The following example, minus 1p. 3 to the power of 2, n times 3 to the power of n plus 1 divided by 27 to the power of n. We see that in the numerator we can immediately apply the first property. 3 to the power of 2n plus n plus 1. To avoid losing the sign or getting the sign wrong, write the expression in parentheses. Divide. And here is the number 27. In order to apply the properties we know, we need the bases to be the same. But the number 27 is a 3 times 3 times 3 times 3. 27 is 3 to the power of 3. So I'm going to write down the number 27 as 3 to the power of 3. And this expression is to the power of n minus 1. In the numerator, I can write 3 to the power of 2n plus n plus 1. Divide. But in the denominator, I have to apply the third property first, and the result is that I have 3 to the power of 3 times n minus 1. I put the expression in parentheses again. Equals in the numerator. 3 to the power of 3n plus 1. In the denominator, I expand the parenthesis 3 times n and 3 times minus 1. The result is 3 to the power of 3n minus 1. Now I can apply the second property. To do this, I will write 3 to the power of 3n plus 1 minus and 3n minus 1 in parentheses. Only after that, I open the brackets. Yeah. And I get 3 to the power of 3n plus 1 minus 3n plus 1. Notice that if I hadn't written the expression in parentheses, then I would have gotten the sign wrong. The result is that 3n and minus 3n is 0. And I would have the number 3 to the power of 2 in my answer. And 3 to the power of 2 is 9. Today we solved examples in which we applied properties, but the exponents were written as a letter expression. Next lesson we will solve some more examples. And for today, our lesson has come to an end. Goodbye, see you again.